Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 16 and today again we will solve a problem based on trees and the level of this question is going to be medium. The name of this question is maximum depth in binary tree. You will get this question link in description and you can also download this Excel sheet from description. Now, without wasting much time, let's see our question on Leetcode. So this is our question on Leetcode. It says, given the root of a binary tree, return its maximum depth. Okay. Now, you might be wondering, what is the meaning of maximum depth? So here is the definition. A binary tree's maximum depth is the number of nodes, right? Hear it very carefully. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So the maximum depth is nothing. It is just the number of nodes, right? It is the number of nodes between a root node and a farthest leaf node. Okay. Now let's take some sample test cases to understand the question more clearly, and then we will try to solve it. So let's say this is our binary tree, and for this binary tree we have to find out the maximum depth. Okay. So right now you can clearly see that this 1 is nothing but our root node and this 2 and 3 are nothing but our 2 leaf nodes. Okay. Now what we have to do, we have to find out the maximum depth. Okay. We have to find out the maximum depth. And what is the maximum depth? Maximum depth basically means the number of nodes between the root node, right? You can say the number of nodes between the root node and the farthest, right? The farthest leaf node, right? The farthest leaf node. So if I ask you what will be the maximum depth for this particular binary tree, it is very simple. See, basically how many leaf nodes do we have? We have 2 leaf nodes. This is the number 1 and this is the number 2. So what we'll do, we can think of, okay, let's calculate the number of nodes between both the leaf nodes and then we will return the maximum node, because a maximum number of nodes, because we have to find out the maximum depth. Okay. So if I take this path, if I consider this path, so here this 1 is my 1 node and this 3 is my another node. Okay. So if I consider this path, you can clearly see that here the depth comes to be equal to 2, right? The depth is equal to 2. Okay. Now if I take this path, and if I again try to count the number of nodes, you can clearly see this 1 is my first node and this is my second node. So how many number of nodes do we have in this particular path? It is again 2. And what's the maximum between 2 and 2? It is 2 itself. So now we can say that the maximum depth for this particular binary tree is equal to 2. Okay. Let's take some more examples. So now let's try to find out the maximum depth for this particular binary tree where this is our root node. Okay. Where this is our root node. So how do we define the maximum depth? So maximum depth is basically the number of nodes between the root node and the farthest leaf node. Okay. So firstly, let's see how many leaf nodes do we have. So this is our leaf node number 1. This is our second leaf node and this is our third leaf node. So we have total of 3 leaf nodes. Okay. Now let's calculate the number of nodes in each path. Okay. In each path from our root to our leaf node. Okay. If I consider this path, then let's calculate the number of nodes. This is my node number 1 and this is my node number 2. So if I consider this path, you can say the number of nodes are equal to 2. Correct. Now let's consider another path. So let's consider this path. Okay. From this root to this leaf node. Okay. And now let's calculate the number of nodes. So here you can clearly see this is my node number 1, this is my node number 2, and this is my node number 3. So in total we have 3 nodes. In this particular path from our root node to one of our leaf nodes. Okay. I hope this is also clear to you. Now let's take another path, right? Now let's take this particular path, right? So what is this path? This path is again from our root node to one of our leaf node. Okay. And if I consider this path and again try to calculate the number of nodes, you can clearly see this is my node number 1, this is my node number 2, and this is my node number 3. So how many total nodes do I have in this particular path? The answer is 3. and still I have to find out the maximum depth. Again, I have to find out the maximum depth. So what is the maximum between 2, 3 and 3? You will say 3. So yes, we can say that the maximum depth for this particular binary tree is nothing but 3. It's nothing but 3. Now if you observe it clearly, then you can say that the height of the binary tree, or the maximum depth of the binary tree, they both are same. Now if I ask you, what is the height for this particular binary tree? For this particular binary tree, what is the height? You can clearly see the height is here 1, 2 and 3. You can say that the height is 3. The height is 3 because if we take a leaf node and if we take a root node, then the maximum distance between a leaf node and a root node is 3. So we can say that the height of this binary tree is equal to 3, or we can also say that the maximum depth of this binary tree is also equal to 3. Now again, let's take one more example to understand this. Okay, so let's say that this is our root node and this is our binary tree, and we have to find out the maximum depth, right? Or we have to find out the height of this binary tree. Okay, so first let's see how many leaf node do we have. This is my leaf node number 1, this is leaf node number 2, this is leaf node number 3, this is leaf node number 4. And we know that the height or the maximum depth of a binary tree is nothing but the maximum number of nodes from my root node to my leaf nodes. Okay, now let's consider every path one by one. Okay, now if I consider this path, I can clearly see the number of nodes are 3, right? This is my node number 1, this is my node number 2, and this is my node number 3. So I can say, if I consider this path from this leaf node to this root node to this root node, then the number of nodes are equal to 3. Okay, now let's take the other path, right? Let's take any other path. Okay, so let's take this path. Correct, because this is again a path between my root node and one of my leaf nodes, right? Between a root node and one of my leaf nodes. If I again ask you, just tell me how many number of nodes do I have in this path? You can clearly see this is my node number 1, this is my node number 2, this is my node number 3. So I have in total of 3 number of nodes in this particular path, right? In this particular path. Okay, now let's consider another path. Now if I consider this path, between my root node and this leaf node, how many number of nodes do I have? You can clearly see this is my node number 1, this is node number 2, and this is my node number 3. So you can say that I have total of 3 number of nodes in this particular path. Okay, let's take another path. Okay, so what's the other leaf node? The other leaf node, remaining leaf node is this 20. So what I can do, I can take this particular path, right? If I take this particular path and if I again ask you, just give me the number of nodes between this path, you can clearly see that this is my node number 1, this is my node number 2, this is my node number 3, this is my node number 4, and this is my node number 5. So if we come across this path, then we can say that the number of nodes are equal to 5, right? And we have 1, 2, 3 and 4 number of leaf nodes. So we have this 4 path, right? 1, 2, 3 and 4. So for this particular 4 paths, we have our number of nodes. Now since we have to find out the maximum depth, right? We have to find out the maximum depth. So what is the maximum between this? The maximum is nothing but 5. So 5 will be my answer. Now if I ask you, give me the height of this binary tree, then the height of this binary tree will also be equal to 5. Why? Because the height of the binary tree is nothing but the number of nodes between the longest path from any root node to any leaf node, right? And this height is again similar to our maximum depth, because the definition of maximum depth and height are both same. Okay, so now I hope you have understood what is maximum depth or what is height of a binary tree. Now let's think of how we can solve this problem. Okay, so let's take this binary tree for example in order to solve it. Okay, so let's say this is the root of my binary tree. Okay, and I have to find out the maximum depth. Okay, see what I can do here. Let me just give you one more example, right? Let's say 1, 2 and 3. Okay, let's say this is a binary tree, and for this particular binary tree we have to find out the maximum depth, right? So see, what will be the maximum depth? What is the maximum depth? Just revise once again. It is the number of nodes between a root node and any one leaf node, right? It is the maximum number of nodes between a root node and any of the leaf node. Okay, so what I can do, I can say, okay, just get me the maximum depth for this left subtree, correct, and get me the maximum depth for this right subtree, right? Maximum depth for this left subtree and maximum depth for this right subtree. Okay, so now this two, does it have any left or right child? You will say no. You will say no. So it is in itself, it is a leaf node. It is a leaf node. So what will the maximum depth or what will be the height of this particular tree? Okay, you will say 1. You will say 1. Okay, so now I can say that the maximum depth or height for this particular subtree is nothing but 1. Okay, similarly, what will be the maximum depth for this particular right subtree? Again, we have just one node. So the maximum depth will also be equal to 1. Okay, so now we know that for this left subtree, the maximum depth is equal to 1, and for this right subtree, the maximum depth is also equal to 1. Okay, now for this root node, 1, what will be the maximum depth? You can clearly see. See, from left what I am getting, let me just rub it once. So you can clearly see for this particular subtree, the maximum depth is nothing but 1, and for this particular subtree, the maximum depth is again nothing but 1. Okay, and what is the maximum depth? It is nothing but the maximum number of nodes. Now if I am attaching, suppose let's suppose that we have just this two, and I am attaching this one, to this two, then what will be the maximum depth? Or more simply, if I ask you, what will be the number of nodes now? So you will say for this particular subtree, the number of nodes were 1. And since we have added this one, to this 2, then we have added one node, right? We have added one extra node. So now the maximum depth or the height will become 2, right? Will become 2. Okay, similarly, let's say that we have just this 2, we have just this node which is 3. Okay, and what is the maximum depth for this 3? It is nothing but 1, or you can say the number of node is nothing but 1. If I attach one more node to this, and if I ask you what is the number of nodes or what is the maximum depth, you will say, since we had one node and we have added one more, then the number of nodes will become 2. So this is the concept which we are going to use, correct? And if we reconstruct the previous tree, and if I ask you what will the maximum depth, you can clearly see that the maximum depth is going to 2, right? If I take this path or if I take this path, the maximum depth is going to be equal to 2. Okay, so this is the concept which we are going to use to solve this problem. Okay, this is the concept which we will use to solve this particular problem. Okay, let's say right now my root is pointing to 1, right? My root pointer is pointing to 1. Okay, what I can say, I can take help of recursion, right? And I will say recursion, hey, just get me the maximum depth for this left subtree, correct? And get me the maximum depth for this right subtree. Okay, get me the maximum depth for this left subtree and get me the maximum depth for this right subtree, right? Once I have the maximum depth from here and once I have the maximum depth from here, right, then I can probably calculate the maximum depth for this root, right? Okay. So this is the scenario. Okay, after that, let's say I came here to this root number 4, to this node number 4, right? Now for this node number 4, I will again say the same thing. I'll say, okay, go and get me the maximum depth for this left subtree and go and get me the maximum depth for this right subtree. So see, in this left subtree, do we have any node? In the left subtree, do we have any node? We will say no, we do not have any node because here we have encountered a null. So now I can say for this particular left subtree, the height or the maximum depth is nothing but 0. So I will give this 0. I'll give this 0 to 4, right? I will give this 0 to 4, correct? And now I will try to find out, the maximum depth for this particular node, okay. Again, I'll do the same thing. I will say, go and first find out the maximum depth for the left subtree and the maximum depth for the right subtree, okay. Now again, we have encountered null values. It means that we do not have any node. If we do not have any node, what will be the maximum depth? Maximum depth will again definitely be equal to 0, correct? So now I will return 0 here, correct? And from here as well, I will return 0, correct? I will return 0. It means that in the left subtree, the maximum depth for the left subtree of this 5 is 0, and the maximum depth for this right subtree is also equal to 0, right? Now, if I add this 5, in my maximum depth, right, then what will be my number of nodes? So you will say that the number of nodes will be equal to 1. It will be equal to 1, right? So since we got 0 and 0 from the left call and the right call, from the left and right call, and if I add 1 to it, I will get 1. So this 1 will be the maximum depth for this subtree, okay. I hope this is clear to you. Let me just rub this. Okay, so for this subtree 5, the maximum depth is equal to 1. So I will just give it to the parent, which is nothing but 4. So I will give 1 here, right? Now at this particular node, from the left call I got 0, and from the right call I got 1. Now which value should I consider? Should I consider this 0 or should I consider this 1? Just ask this question to yourself. Okay, we should consider this 1, right? We should consider the maximum value between these two, right? The maximum value between these two. Why so? Because we have to find out the maximum depth, right? See, if I consider this path, then what will be the maximum depth? The maximum depth or the maximum number of nodes will be equal to 2, correct? Or if I consider this path, then you can say the maximum number of node is going to be 1, which is this 4 itself, right? And since we have to return the maximum depth, we will consider the maximum between the 0 and 1, right? What is the maximum? Maximum is 1. The maximum is 1. Now what this 1 signify, right? It signifies that the maximum depth between the left subtree and the right subtree of this node 4 is 1, right? Okay. Now if I add this node number 4 to this particular node, then I am adding one extra node, right? So the maximum depth will get increased by 1, because maximum depth is nothing but the maximum number of nodes, right? So now I will add 1 here. It will become 2, and now I will pass this to my root node, right? To my parent node. Okay. So now you can say that now I am standing here, right? With 2, right? I got 2 from the left call. Now I'll go to the right. Okay. See, I'll come here at the right. Okay. Now again, for this node number 2, I'll say, hey, get me the maximum depth for the left subtree and get me the maximum depth for the right subtree. Okay. Get me the maximum depth for the left subtree and get me the maximum depth for the right subtree. Okay. So here in the left subtree, you can clearly see that we have null, or we do not have any number of nodes, right? So this left will return 0. It will say, hey, in the left, I do not have any node. Since I do not have any node, the maximum depth or the height will be equal to 0, right? Okay. So now I'll try to find out the maximum depth of this right subtree, right? Okay. So I'll come here. I'll come to this particular node, right? I'll come to this particular node. From here, I will again do the same thing, right? I'll say, hey, go and get me the maximum depth for the left subtree and go and get me the maximum depth for the right subtree. Okay. Now here in the right subtree, you can clearly see that we are having a null value, right? So you can say that at right side, we do not have any number of nodes. If I do not have any number of nodes, then the maximum depth or height will be equal to 0, right? So from right, I will get 0 here. I will get 0 here. I hope it is clear to you, right? Now let's get the height. Let's get the height of this particular subtree, right? Of this particular subtree. Okay. So for this particular subtree, again, I will say the same thing. Go and get the height of the left subtree. Go and get the height of the right subtree. Okay. Now here you can clearly see at the left we have null and at the right we also have null. It means that in the left subtree or in the right subtree, we do not have any number of nodes. Since we do not have any number of nodes, then the maximum depth or the height of the left and right subtree will be equal to 0. Correct? Will be equal to 0. So from here, we will return 0. And from here, we will again return 0. We will again return 0. Okay. Okay. So see, what does this 0, 0 signifies? It signifies that for this particular 8, at the left, we do not have any node. Right? At left, we do not have any node. And at the right also, we do not have any node. Right? Now, if I consider this node number 8, if I try to add it into a maximum depth, if I try to add this node 8 into a maximum depth, then what I'm doing, I'm adding one extra node, right? I'm adding one node. If I'm adding one node, and since the maximum depth is nothing but the maximum number of nodes between a root and a leaf node, so the number of nodes will get increased by 1, right? The maximum node, the number of node will get increased by 1, right? Or you can also understand in this way, from left I'm getting 0 and from right also I'm getting 0. Correct? If I add this 8, so which value should I consider? Should I consider this 0 or should I consider this 0? You will say, what you are talking about? Both are same. Okay. But since we have to consider the maximum value. So since if we try to find out the maximum value between the 0 and 0, it will be 0. It will be again 0. So in this 0, I will add this 1. Why I'm adding this 1? Because now I'm considering this node 8. Right? Now I'm considering this node 8. Now the maximum depth will become 1. Right? Now the maximum depth will become 1. So I will return this 1. I will return this 1 to this node number 12. Right? Now here at this node number 12, we have 1 from the left call and we have 0 from the right call. Now which one should I consider? Which one should I consider? Since I'm trying to find out the maximum depth, I should consider the maximum value. I should consider the maximum value. So what is the maximum between 0 and 1? You will say the maximum is nothing but 1. Now if I add this node number 12, to here, right, to this particular node 8, then how many number of nodes will I have? I'll have one extra node. It will be equal to 2, right? So if I add 1 plus 1, I'll get 2. Now what I will do, I will just return this 2 to this particular node number 2. Correct? To this particular node, which is node number 2, right? Now if you clearly see, at this particular node, from the left call, we got 0. And from the right call, we got 2, right? From the right call, we got 2, correct? Now, which value should I consider? Again, I should consider the maximum value because I'm trying to find out the maximum depth. Right? So see, right now what we have? Right now we have these 2 nodes. And due to these 2 nodes, the maximum depth we got is equal to 2, right? Now, since if I add this 2 to this particular subnode, then how many number of nodes will I have? I'll have one extra node. So what I'll do, I'll take the maximum, which is nothing but 2. I will add 1, and now the maximum, or you can say the maximum depth or the height will become 3, right? Now the maximum depth or the height will become 3. So before moving forward, let me just clear this mess. So now you can clearly see up to this point, right? Up to this point, the maximum depth is nothing but 3, or you can say the maximum number of nodes is nothing but 3. So what I will do, I will just give this 3 to its parent. And who is the parent? The parent is nothing but 1 here. So I will give 3 here, right? Now if you clearly see, from the left call, we got 2, and from the right call, we got 3. Which value should I consider? Again, I should consider the maximum one because I'm trying to find out the maximum depth, right? So what is the maximum? Maximum is nothing but 3. The maximum is nothing but 3. Now see, since I am considering this maximum value 3, what does it mean? It means that I'm considering this path, right? I am considering this path, okay? So I have this path, and in this path, I have 3 number of nodes. This is my node number 1, this is my node number 2, and this is my node number 3, right? So in this 3 nodes, if I add this extra node to this particular path, then how many number of nodes will I have? yes, I'll have one extra node, right? Therefore, I will add 1 here, and now I will have the final answer as equal to 4, right? Now I'll have the final answer equal to 4. And what does this 4 signify? This 4 signifies that this is nothing but the maximum depth, right? And this is the path. This is the path of the maximum depth, right? If you count the number of nodes, then the number of nodes is nothing but 1, 2, 3, and 4. And this is what we are getting, right? This is what we are getting. So this was the approach. I hope you have understood the approach. If you have some issues, if you are a bit confused, then I would recommend you to take some sample test cases and do a dry run by yourself, right? The concept is very easy. Whenever I am standing at a root node, I am saying just go and get me the maximum depth of the left subtree, and go and get me the maximum depth of the right subtree, right? Once I have the maximum depth from the left and from the right, I'm considering the maximum value. I'm considering the maximum value, and then I'm just adding +1 into it, right? And I'm returning it to the parent, right? Why I'm adding this one? Because now I'm considering this particular root node as well. Okay, so I hope it is clear. Now let's think of how we are going to code this problem. So now let's think of how we are going to code the approach which we have just discussed. So the coding part is going to be very easy. See, what we will have, let's say we have a function, and inside the function we are getting our root node, right? We are getting our root node. So let me just explain you again with an example. So let's say this is nothing but a binary tree, right? And for this binary tree, we have to find out the maximum depth. And here is a root pointer pointing to. Okay, what I'll do, I'll say go and get the maximum depth for the left subtree. Go and get the maximum depth for the right subtree. Okay, this is my first task. So how I can write this in code? I can simply write int left max is equal to function root left, right? Function root left. So from this function call, I will have the maximum depth in this particular left max variable, right? Similarly, I will write int right max is equal to function root right, right? Function root right. Okay, so from this particular function call, I will get the maximum depth for the right subtree, and it will be saved in this particular variable, Now what's the next task? I have to find out the maximum between these two. I have to add one, right? And then I need to return it, correct? Then I need to return it. So how I'll do that? I will simply write return the maximum of the left max and the right max plus 1, right? And the right max plus 1. So what we are doing, we are basically finding out firstly what is the maximum between the left max and the right max, right? What is the maximum between maximum depth of the left subtree, and what is the maximum depth of the right subtree, right? We are taking the maximum of both the two values, and then we are adding 1, and then we are returning to the parent. Okay, so this is going to be our recursive, right? This is going to be our recursive relation. Now again, if you see this code, then we are missing one thing, which is nothing but our base case, right? Which is nothing but our base case. Let's think of our base case. Okay, let's say I have just this one node, right? And here also I have null, and here also I have null value, right? I have null and null values. Now if I say go and get the height of the left subtree, go and get the height of the right subtree. So here you can clearly see when I'm encountering a null, it means that I do not have any node in this particular left subtree, right? Similarly, when I'm encountering a null here, it means that in this right subtree also I do not have any number of node. And what is the maximum depth? Maximum depth is nothing but the maximum number of nodes between the farthest path from my root node to one of my leaf nodes. Okay, so now since I have zero number of nodes, therefore I will return 0. Since I have zero number of nodes, I will return 0. Then I'll take what is the maximum between 0 and 0. You will say 0. Then I will add 1. Due to this particular node. Then I will return 1. Okay, so the basically conclusion of this particular example is whenever we are encountering a whenever we are encountering a null value, we have to return a 0, right? So what I'll do here, I'll simply write if my root is equal to null, then kindly just return 0, right? Then kindly just return 0. So this is our code. I hope the code and the approach is clear to you. If I explain you the time complexity, then the time complexity is going to be O of n. Why O of n? Because we are traversing every node exactly one number of time, right? For every node. See, we are covering this node, we are traversing this node, this node, this node, and this node, and this node. Only one number of time, right? Therefore, the time complexity will be equal to O of n. And if we talk about the space complexity, then it will be equal to the height. It will be equal to the height of our binary tree, correct? And you can say that in worst case, the height of the binary tree can also be equal to O of n, right? Let's say, let me just give you an example. So let's say we have a binary tree which look like this, right? Which look like this. Okay. Now, if I ask you what is the height, you will say 1, 2, 3, 4. The height is equal to 4. And if I ask you what is the number of nodes, you will again calculate it same, right? This is 1, 2, 3, 4. So height is also 4 and number of nodes is also equal to 4, correct? So we can say that in worst case, the space complexity will be equal to O of n. And why even there is a space complexity? It is due to the recursion, right? We are using recursion, therefore we will have some recursive call stack. Therefore, we are getting a space complexity equal to O of n. So I hope the code and the intuition is clear to you. Now let's fastly code it up on Leetcode. So here we are on Leetcode. Let's fastly code the approach which we have just discussed. So very firstly, I need to write my base case that if my root is equal to null, then just return 0, right? Just return 0. If this is not the case, then go and find the maximum depth for the left subpart for the left subtree and find out the maximum depth for the right subtree. Okay. So I'll write int left max is equal to max depth root left, right? Root left. So from this particular code, from this particular line of code, I will have the maximum depth for the left subtree, right? Now I need to find out the maximum depth for the right subtree. So I will write int right max. I will write int right max is equal to max depth of root right. So from this particular line, I will have the maximum depth for the right subtree, right? Now what I need to return? I need to return the maximum. Firstly, I need to calculate what is the maximum between the left max and the right max, correct? So I'll write max of left max and right max, correct? And after finding out who is the maximum, I just need to add 1 to it. And then I need to return it. So this is our code. It is pretty simple and pretty short. What we are doing, this is nothing but our base case, that if at any point my root is equal to null, then I need to return 0, because when I'm encountering a null, it means that I do not have any node. Since I do not have any node, therefore I'm returning 0, correct? From this particular line of code, we are getting the maximum depth for the left subtree, correct? And from here, we are getting the maximum depth for the right subtree, okay? And then we are finding out what is the maximum between the left max and the right max. Then we are adding 1, and then we are returning it, right? So this is our code. Let me just run this. So here you can clearly see that all the 3 sample test cases are running fine. Let me submit this. So here you can clearly see that this particular approach is accepted. I have already explained you the intuition. I have already explained you the time and space complexity and the code. So I hope this video is helpful to you. And if it was, then make sure that you like to this video. If you have any different approach, or if you are facing any problem in the code of this particular problem, please comment it down. And if you want this type of content regularly, then make sure that you subscribe to this channel. And this was all for this particular day. We will meet again tomorrow with a new question.